The cosmic trap. What actually happens? Inside a black hole, imagine driving down a highway where the speed limit isn't just a law, it's a fundamental rule of the universe. You're traveling at the speed of light, 186,000 miles per second. Nothing can go faster. But up ahead there's an off-ramp. You take it and suddenly the road collapses into a point of infinite darkness. You try to hit the brakes, you try to reverse, but even at the speed of light you are pulled downward. Welcome to a black hole. These aren't just cosmic vacuum cleaners, they are regions of space-time where gravity is so intense that absolutely nothing, not even light, can escape. But what actually happens if you fall into one? To understand the trap, we have to understand how it's built. Most black holes are born from the deaths of massive stars, monsters at least 20 times larger than our sun. Throughout its life, a star is in a constant tug-of-war. Nuclear fusion in the core pushes outward, while gravity pulls inward. It's a perfect balance, but eventually the star runs out of fuel. Without that outward push, gravity wins instantly. The star's core collapses in on itself in a fraction of a second, while the outer layers explode in a violent supernova. What's left behind is a corpse so dense, with gravity so concentrated that it punches a literal hole in the fabric of the universe. If you were to approach a black hole, the first boundary you'd encounter is the event horizon. Think of this as the cosmic point of no return. Outside the event horizon, you can still escape if your rockets are powerful enough. But the second you cross that line, the escape velocity required exceeds the speed of light. Because nothing can travel faster than light, nothing can cross back out. But here is where physics gets genuinely weird. Thanks to Albert Einstein's theory of relativity, we know that heavy gravity warps time. If I were watching you fall into a black hole from a safe distance, I would see your clock tick slower and slower. As you reach the event horizon, you would appear to freeze in place, fading into a faint red mist. To me, you never actually cross it, but from your perspective, you cruise right through the barrier, completely unaware that you've just been erased from the rest of the universe's future. Once you're inside, your destination is fixed. You are falling toward the singularity, the mathematical center of the black hole. As you fall feet first, the gravitational pull on your toes is drastically stronger than the pull on your head. This extreme differential creates a real astrophysical phenomenon playfully called spaghettification. You are violently stretched out into a long, thin string of atoms. At the very center lies the singularity. This is a point where an entire star's mass is crushed into an infinitely small space. Here, density becomes infinite. The curvature of space-time becomes infinite. And our laws of physics? They completely break down. General relativity and quantum mechanics clash, leaving scientists with a giant question mark. Black holes are the ultimate paradox. They are dark, yet they power the brightest galaxies in the universe. They are dead stars, yet they might hold the key to understanding how our universe began. They are places where time ends and where our imagination is forced to begin. Next time you look up at the night sky, just remember, out there in the dark, the universe is hiding secrets we are only just beginning to unlock. Thanks for watching. If you want to keep exploring the cosmos with us, hit that subscribe button and we'll see you in the next video.